Hey guys, you can open your notes to page 15 and we'll wait for you to get the note packets out to page 15. We're going to be moving on to the next section today on 11.3A. We're going to be working with some division. So it's a nice easy section, the first part. The second part, tomorrow's, is actually quite difficult. But today we have a nice easy task because we're only going to be dividing by a monomial. Once we start making that a binomial and have to do some long division, it's going to get a little hairy. But for today, dividing by a monomial is a piece of cake. Before we take notes on that, what I'd like to do though, I'm going to go back for a second here, is just to revisit where this chapter is going. And again, I'm going to tie it into when you first learned fractions in about the 5th or 6th grade. Remember, what we first learn how to do is we first learn how to simplify. And they teach you that you divide out a 3 and divide out a 3, which is actually called a common factor, leaving you with 1/2. Hence, 3/6 is a half. And you have simplified it. Well, again, really what you're doing is you're saying, well, there's a 3 on top, and you're factoring, really, 6 on the bottom, and you're canceling common factors. And that's exactly what we do with our polynomial simplification. So if I were to ask you to simplify 2x minus 6 over x squared minus 9, again, huge in this chapter. We don't go canceling until we factored. Again, I can't cancel this x right here with this x right here because it's not a factor. It's both of them are a part of a difference. So I need to factor the top, and that's an easy one to factor, 2 times x minus 3. I need to factor the bottom. Now this is the easiest kind of factoring that you can possibly get if you can spot it. We did a couple of these yesterday. Remember, this is our difference of squares, which factors into or unfoils to equal x times x, 3 times 3, and to create that cancellation when we foil, we need to have a positive and a negative. Now, if you're asked for excluded values you determine before you cancel. So we factor, we cancel. But if you're asked to find or state the excluded values, you have to do it between those two operations. So I have just factored before I cancel. If I had to state the excluded values, remember that's what causes our denominator to be equal to 0. So I have to decide what number or numbers would cause a 0 on the bottom of this fraction. And this is easy to determine. I would say that my excluded values for this one would be, and a lot of times we write that as EB. I think on your quiz you're going to take in about 5 minutes, it'll say EB for excluded values would be -3 for this, would make that factor 0, and 3 for this one. Now I cancel, leaving my simplification of 2 over x plus 3. Once we did simplification, then we went to multiplication, and then we did division of fractions, and now we're going to be doing division of monomials. So we're still in the division realm, but again, we're going to do a little repeating first because today is easy, and we have a quiz coming up here in a little bit, so I want to make sure we've got all our ducks in a row for the quiz. So before we do anything new down here, we're going to review a multiplication problem. So again, I do not start canceling. I factor first. If you get nothing out of this chapter, factor first. It's our favorite F word. We do it every single time. So on the top of here, I should notice, I've got a difference of squares. We've had a lot of those in our last few chapters. On the bottom, another difference of squares. Gee, do you think there might be a difference of squares on your quiz? Perhaps. The top right here is already factored, so it can remain, sorry, that should be multiplied. It can remain unchanged. And on my bottom left, I have a common 2 that can be factored or divided out of both terms. Now I cancel. I've got an x plus 6 and an x plus 6, an x plus 1, and an x plus 1. And I've got a 2, and I've got a 2. So when I'm all done with this, my simplified product would be x minus 6 over x minus 1. Again, had it said to state the excluded values, I would have done it between the factoring and the canceling. It's kind of like a sandwich. Put it right in between the two. So I would have said 1 causes a 0, -1, and -3 would have been my excluded values. I'm sorry, -6. What was I thinking? Anywho, when we do division, right, so division wasn't any more difficult than multiplication, which is why that was a pretty short lesson for us. Because division, remember, we just multiply by the reciprocal. We talked about how if you had 10 slices of pizza and you're going to cut or divide them each into halves, the amount you have ends up doubling, leaving you 20 pieces. We multiply by a reciprocal when we're dividing by a fraction. So our first step in the process is going to be to leave this first part unmessed with. Again, do not start canceling. Factor first, all right? Times, and I'm going to do the reciprocal of the second part, putting a 4x squared on top and x squared minus 36 on the bottom. Then what I'm going to do is I'm going to go factor everything that can factor. Well, this is the only part that can't factor. So the other ones, we remember whenever we have our trinomial, we try to unfoil it. We've been doing that for a long time. What multiplies to equal 30, technically negative 30, well at the same time can add up to a negative 1. And we can spot that really quick that we can use 6 and 5 as long as the 6 is negative. So we'd have x minus 6, x plus 5. And I think I've got 95% of you factoring this kind and this kind very well. So that's good. We're still working on a couple of you with when there's a lead number out here, but we'll get there. On the bottom, we have a 2 in common. Number one rule of factoring is, can I pull anything out of every term? That was a no up here, but on the bottom, a 2 can be divided out. This top, I won't mess with. And then look on the bottom, I've got a difference of squares. So x plus 6, x minus 6. They're the easiest kind if you spot them. All right, now that I'm all factored, now I can cancel. Okay, so I'm going to go x minus 6 with the x minus 6, x plus 5 with the x plus 5. I'm going to divide out a 2, divide out a 2. And let's see what we have left. On the top, it looks like the only thing left on the top is a 2 and an x squared. So we've got 2x squared. And on the bottom, just an x plus 6. And I want to reiterate here, I cannot cancel. So go ahead and circle that. And don't do what I'm going to do next. I cannot cancel the 2 with the 6 because this really is not a 6 on the bottom. It's part of a sum. If x itself was, say, 5, on the bottom of this you actually have an 11. There's no 6 in there. So when it's living next to a plus or minus, or part of a sum, or part of a difference, or in part of parentheses, we do not cancel. So my final answer to that would be 2x squared over x plus 6, and nothing in there cancels. So now our new stuff. And our new stuff won't take me very long at all because it's a nice, easy task for us today. All right? So, if I can move my screen, there we go. What are we going to do today? Again, that was all a review. You've got a quiz coming up today, so I wanted to do a little review. We're going to divide by a monomial. It's the easiest thing to divide by. But we got to remember what a monomial is from our last chapter, or 2 chapters ago. A monomial is a polynomial with just one term. Mono meaning one. Okay, so with just one term, really what that means is it's not separated by any pluses or minuses. It's just one term here, like 3x squared. Now, if that was divided by 3 plus x squared, we've got a whole nother problem to deal with. But if I'm dividing by a monomial, it's very easy, and it kind of goes back to, again, I like to take you back and have you work with numbers so you can see. So I'm going to put something you know up here. 8 plus 2 divided by 2. When I'm just over a single number like this, you know the answer is 10 divided by 2, which is 5. And we already talked about how that kind of allows us to see that canceling here is very naughty. Obviously, 10 divided by 2 is not 8. But what it also allows you to see is that when I've got this 8 plus 2 over 2, which by common sense I know is 5, I can actually view that as being split apart as 8 over 2 plus 2 over 2. Notice, because again, when you have a common denominator, you keep it and add the tops. So you can see that that would give me a 4 plus 1, or a 5. So it's very legal to split up a fraction as long as it's over just a single monomial. Now, again, Had that been 8 plus 2 over 3 plus 5, now I can't split it up because I don't have a monomial or a single term down here. So let's go take a look at what we're going to do with this one. We're going to split it up. I'm taking a whole quantity and dividing it by 3x squared. What that means is every single term can get divided by 3x squared. So I'm going to give you a little bit to write that down. I don't have a whole lot of time left on my recorder, about 4 minutes, but this is easy. I'm done actually right down here. So a nice easy lesson. When I'm dividing by a monomial, I simply take every term, because it's in parentheses, and I divide each one by 3x squared. And this takes us back to our rules of exponents. What do we do with exponents when we divide? Like say x to the 5th over x to the 2nd. Well, we say 2 of the ones on the bottom, we cancel out 2 of the ones on the top, leaving 3 on the top. Or our rule said we subtract the exponents. So you can picture canceling or subtraction, but I think it's almost safer just to picture canceling. So let's go take a look up here. Now I got to divide each. Well, what is 9 divided by 3? That would leave a 3 up on top. X cubed divided by x squared would leave an x on the top. So that's just a 3x over 1 if you would like, but that's just a 3x minus 6 divided by 3 is top heavy, leaving a 2 on the top. X squared, those two x's will completely wipe out those two x's. Now, if you used your rule that says you subtract the exponents, would that hold over here when I have x squared over x squared? We'll try it. X to the 2 minus 2. That's x to the 0. And we've had a lengthy discussion in another chapter about how anything to the 0 power is 1. All right? So these completely cancel, leaving a 1. All right? The next pair, 15 divided by 3 is top heavy again, leaving a 5 on the top. Keep in mind if it had been 3 over 15, it's bottom heavy, leaving a 5 on the bottom. So you got to be careful where you leave it. Now, this 1x on the top will cancel out one of them on the bottom. So it's going to leave an x on the bottom. And here is my answer. So, last one up, my friends. I'm only doing 2 examples of this because this should seem very easy for you after all the factoring and canceling and everything we've been doing. Dividing by a monomial. All we simply do is split it up first. So I'm going to take 4a cubed and I'm going to divide it by 2a squared. I'm going to take my 10, a to the, what is that? It looks like an a to the a on mine. Let's pretend this is a typo. Let's make it a to the 5th. I don't know what that is. Maybe it was an a to the 0. I don't know. But we'll write it like that. We'll change that to a 5 and we'll just tweak it there. And then the last one. So I'm going to take every single term, break it up, and divide it by 2a squared. And now I simply just reduce each individually. 4 divided by 2 leaves 2. 3a's on the top. 2a's on the bottom will leave 1a on the top. Plus, 10 divided by 2 is 5. 2a's on the bottom will wipe out 2a's on the top, leaving a to the 3rd. Or if you like to say it's 5 minus 2, leaving a 3, go ahead for those exponents. Plus, nothing cancels here with my 3 halves, so it remains 3 over 2. And on the next one, this a is going to cancel out 1 down here, leaving an a on the bottom. Or, again, if you like to picture that subtraction, it'd be a to the 1 minus 2, which is a to the negative 1. And in our other chapter, we said a negative 1 sends it to the basement to be more positive. Or we take the reciprocal for 1 over a. Either way, I think it's just safer to picture canceling, and you're going to end up with an a down on the bottom. So what are we doing the rest of the hour? Your assignment's written on the bottom of this page. It is also on the front of your packet. This is what is due tomorrow. Right now, you're going to be taking a quiz, not on this stuff, but on 11.1 to 11.2. You are allowed to use your notes. So what I'd like you to do is page back to your 11.1A notes. You have those out. Mr. Bloom or Mr. Deskin will pass out the quizzes. You'll take that. You'll turn it in, and then you will work on this assignment. So we're going to be totally quiet the rest of the hour, quizzing and